Okay, we're going to talk today about functions and what a function is. And before we start talking about functions, we're going to look at what a relation is, because a relation helps you figure out functions. So find your notes page. It's blue. It's titled Wednesday in the top right-hand corner. And fill in your notes as we go through my notes page. All right, so the definition of a relation is a set of ordered pairs. Remember, if I ever go too fast through the video, you can always pause to catch up or rewind or whatever you need to do to stay with me. All right, so a relation is simply a set of ordered pairs. Ordered pairs, remember, is an x comma y. And so you would have a set of these, and they can be shown as a list, they can be shown in a table, a mapping, or a graph. So I'm going to show you guys what that looks like with these three examples. Also, with a relation, you have a set of x values and a set of y values. The x values are called the domain, and the y values are called the range. So if you ever hear me say to state the domain, I'm asking you to list the x values in your relation. If I'm asking you to state the range, then I'm asking you to state the y values in your relation. All right, so there's three examples here in which we're going to take a set of ordered pairs, and we're going to display it in a table, a mapping, and a graph. And we're also going to talk about the domain and the range. So first, let's take these ordered pairs on the first example, and we're going to put them in a table. Order doesn't matter. I just do my first ordered pair and put it inside of the table. X's go under the X column, Y go under the Y column. The next ordered pair could go underneath of that, so forth, and so on, until you have filled up your table. Then, for a mapping, order does matter. So mappings have a little bit of rules. The rules are the first bubble is your X's, the second bubble is your Y, and you're going to list your X's in order from smallest to biggest. And you're also not going to put any repeating values. So if you have, for example, on this first one, we've got two -3s. I'm only going to put one -3 into the X bubble. So I'm going to list them from the smallest number, which is a -3. Remember, only put that in there once, even though there's two of them, followed by a -2, then a 1, then a 3. So you have to list your numbers from smallest to largest, and if anything repeats, you only put it in the bubble once, and you stack them up, you line them up. So my Y column, we're going to do the same thing. We're going to take the smallest number, which is a -4. Then we have a 0, 1, 2, and a 5. So none of those repeated, so I had to list all of the numbers. And then to complete your mapping, you simply draw an arrow that connects the ordered pairs together. So -3 maps to the 1, because that's my first ordered pair. -2 goes to the 0. 1 goes to the 2. 3 goes to the -4, and then I have another -3 that went to the 5. So there's two arrows coming out of that -3 because it repeats. And that is what a mapping looks like. They're kind of neat. And then a graph, you just take your ordered pairs and you graph them. Remember the x-axis and the y-axis. It's very helpful if you label both your x and your y-axis. And to graph an ordered pair, you should remember that from previous years in math class. -3 is to the left 3, and then up 1. So I'd put a dot to the left 3, up 1, and that is -3, 1. -2, 0 is to the left 2, and then go nowhere up or down because that's a 0 value. To the right 1 and up 2. To the right 3 and down 4. To the left 3 and up 5. So that is what those ordered pairs look like graphed. Now if you want to, you can, oh wait, let's talk about domain and range. Domain are your X values. We don't list any repeaters, and we also generally list those from smallest to largest. So I look at my mapping bubble, and I pull out my numbers from my mapping. So I basically take this, and I write it over there. So you can always take your mapping to help you display your domain and your range. All right, so my range, same thing. I'm going to look at my Y bubble. And I'm just gonna list those numbers. So they go from least to greatest, and you don't put anything that repeats. So that's really important. So I'll make a little note up here. Least to greatest, and no repeaters. So if you see two of them, just write it down once. That's how you do a mapping. All right, so now if you want to pause the video and you can try number 2, fill in the domain, the range, the table, the mapping, and the graph, and then you can unpause the video and see if it matches my solution. So I'm going to go ahead and put in my values. Hopefully you are checking your work because you have now unpaused me. And you're going to check your solution. So I'm going to go from smallest. Well, that's nice. They already had them in order for me. And same thing on the other side. Notice there's 2 4s, but I only put 1. And then I'm going to draw arrows to connect my ordered pairs. I'm just looking at my table to help me connect my ordered pairs. And then I'm going to graph carefully, making sure I don't make any mistakes. It can be very tedious. 0, go nowhere, go down 2. 2, 1, 2, 3, 4, 5, -1, and that should be correct. My domain are my x's in order from least to greatest, no repeaters there. And the same thing with my range from least to greatest, no repeaters. Remember, your domain are your x values, your range are your y values. Oh, so how did you do? Hopefully pretty good. Again, you can pause the video and you can look at the last one. They didn't give me any ordered pairs. Oh, they gave me a graph though, so we got to work backwards. So if you noticed over here, they gave you ordered pairs. So now we have to figure out the list of ordered pairs. So let me see. This first, I'm going to go in the first quadrant. This is the first quadrant, by the way. Second quadrant, third quadrant, and fourth quadrant. Oops, I missed my little tick mark here. There you go. So I'm going to look at my first quadrant. I have 1, 2, 3, 4, 4, 2. Doesn't matter who you write down first as long as you get all the points. So I've done that one. Let's go over here to this next one in the second quadrant. -2 up 3, so -2, 3. I'm going to go down here to the third quadrant. It looks like we've got 1, 2, 3, 4, 5. To the left, it's -5. 1, 2, 3, 4 down. So -5, -4. We have one on the y-axis, 1, 2, 3. So that's 0, -3. And in my fourth quadrant, I already got that one. My fourth quadrant is to the right 2 and down 5. To the right 2 and down 5. Remember, left is negative, down is negative, up and right are both positive. That was interesting. All right, my table, you simply just write your ordered pairs into the table. Make sure that your X and your Y's are lined up. Doesn't matter who you write in there first. X bubble, Y bubble, in order from least to greatest, so -5, -2, 0, 2, and 4. -5, -4, -3, 2, and 3. Now I'm going to connect. Let's see here. 4 goes to 2. -2 goes to +3. -5 goes to -4. 0 to -3. And 2 to -5. So that is what that mapping looks like. Your domain are your X values from least to greatest. And same thing with your range. It's your Y values from least to greatest. And that is a relation. That is how you can show a relation as a set of ordered pairs, a table, mapping, or a graph. And then from that you can state your domain and your range. All right, the next thing we're going to look at, save that, is functions. So find the next paper. It's also got Wednesday at the top. Well, let me edit it here. All right, now I can write on my document. So at the top it's got Wednesday, so find that paper. We're going to talk about what a function is. A function is a special relationship between values. Each input, also known as your x values, has exactly one output. So how do we determine if a relation, remember relation is a set of ordered pairs, so how do I know if the set of ordered pairs is a relation? If the set of ordered pairs, which is a relation, is a function. I get my words right here. All right, so to test whether a relation is a function, if you have ordered pairs, you're going to look at just the x values. I don't care about the y values. They can do whatever they want to. But your x values, if they repeat, then it's not a function. This is super important. If your x values repeat, then it is not a function. If you have a graph, we use the vertical line test. If a vertical line intersecting a graph more than once, then it is not a function. And I'll show you guys that. I can actually use my ruler when I talk about that. My ruler can be my vertical line, and I can move that across the graph, and then we can see if we hit more than one point or not. So we'll get there. All right, so first let's take a look at these relations and determine if they're functions or not. So again, I'm only going to be focusing in on my x values. So if you want to circle, underline, or highlight your x values, remember that is the first number in a set of ordered pairs. So if I take a look at the first number in each ordered pair, I want to ask if any of those values repeat, any of them the same. So I got a 5, 3, 2, 0, and -1. None of those values repeat, so therefore this is a function. Determine whether the following is a function. Number 1 is yes, it is a function. And again, I can do that for number 2, 3, and 4. Just find the x values and determine if they are functions by looking at those x values. So if you want to, you can pause the video, look at those x values, and if they repeat, it's not a function. If it doesn't repeat, then it is a function. All right, so number 2, because I've got 2's that repeat, this is not a function. And you can just put no. Number 3, I have the -3 values that repeat, so this is not a function. And number 4, I have 1, 2, 3, 4, 5, so nothing repeats, so yes, it is a function. So again, super easy. Look at your x values. If they don't repeat, then it is a function. If they do repeat, then it's not a function. Well, remember we talked just a second ago about relations. You can show them as a table. Again, I'm only worried about my x values. So circle your x column, highlight your x column, something that would just let you focus in on your x's. I don't care what my y values are doing. So if I take a look at my x values, I'm looking to see if anything repeats. So on number 5, I have repeaters, so it's not a function. Number 6, I don't have anything that repeats, so yes, that's a function. Number 7, and again, you can pause this video and see if you can determine if they're functions or not without me telling you beforehand. This one is a function, and this one's got 4's that repeat, so it's not a function. All right, the third type of relation can be shown as a mapping. So if I take a look at number 9 and 10, these are both mappings. And remember, the first bubble are your x's. So I'm only going to focus in on my x's. And I'm going to look to see if any of these x values repeat. And the way that you can see if they repeat is if any of the numbers in the first bubble, your x bubble, if any of them have 2 arrows coming out of them. So each one of these only has 1 arrow leaving the number. So this one is a function. Number 9 is yes. Take a look at number 10. See that -1's got 2 arrows going out of it? So this one tells me I've got -1 twice. It goes to the 0 and it goes to the 7. So this one is not a function because -1 repeats. All right, lastly we have the equation, trying trying to talk and do something at the same time here. All right, next we have the graphs. So the graphs, remember, we want to use what's called the vertical line test. So I'm going to show you what that looks like. You can take your pencil and hold it vertically, which is up and down, or you can use a ruler. I'm going to use my little ruler here. And so if I go across this graph, I want to make sure that there's no points above or below each of these individual points. So this one, there's nothing above or below that point, so I can keep going. Only one point here. What happens when I get right here? I hit 2 points at one time. If you notice, I'm hitting 2 points at one time. So this fails the vertical line test. This one fails the vertical line test. And because it fails the vertical line test, this is not a function. And again, you can just put no, not a function. All right, let's take a look at number 12. Anything above or below that dot? Nope, we can keep going. Only 1 point there, only 1 point there, and only 1 point there. So this one passes the vertical line test. This one is a function. And you would do the same thing for each of these. Take your pencil and hold it vertically, or if you have a ruler nearby, you can do that too. So and I always go from left to right. It doesn't matter if you go from right to left. I've just been trained to always sweep my vertical line to the left. So on number 13, as I go, I'm stopping at each point, and then what do you notice here? I can't keep going because I'm hitting 2 points. So you almost think about it as a wall. 2 points make a wall. So this is not a function. Number 14, this time I don't have dots, I have a pretty little graph. So as I'm taking my vertical line and I'm sweeping across, if you notice right here, I'm hitting 2 pieces of that line on top and on the bottom. So this one fails the vertical line test, because even if I draw a vertical line right here, you notice I'm hitting my graph there and there. So this is not a function. It fails the vertical line test. Number 15. I don't know, is that supposed to be there? No. All right, number 15, making sure my paper looks like yours. I had an extra line in there. So if I go across with my vertical line here, there's no other pieces above or below anywhere on this line, except for the y-axis and the x-axis. That doesn't count. So if I look, there's no points above or below my line. So I can sweep this ruler straight across, and there's no x values that repeat, because what you're looking for is to make sure that there's no x's that are the same for 2 or more ordered pairs. So this one is a function. This one's a yes. Number 16, if I take my ruler and I sweep it across, there's nothing above or below anywhere on my curve. There's no other points anywhere above or below. So this one passes the vertical line test as well. There's no dot, like, for example, let me do it in red. There's no dot here or no part of a line right here which would indicate it would fail the vertical line test. So this one is good to go. It passes the vertical line test, so therefore it is also a function. Okay, so just remember, if your x values repeat, it is not a function. And so your assignment, after you have done these practice problems with me, is to go into Delta Math, and you have 2 pieces or 2 sets of questions. One tells you to look at the ordered pairs to determine if it's a function, and the other one is graphs. So you're just going to use the vertical line test on the graphs, and you're going to look at the x values when you're given a set of ordered pairs, just see if the x values repeat. So use your notes to help you do your Delta Math assignment, and then remember to mark complete or mark done in Google Classroom, and that lets me know that you are finished with today's assignment. And if you have any questions, please remember you can always message me on Remind, or you can email me, and my office hours are going to be on Wednesday from 11 till 12 noon. All right, guys, see you next time.